Welcome to College Algebras in 4.4, where we will be discussing exponential and logarithmic equations. All right, so we'll be looking at solving exponential equations by expressing each side as a power of the same base class. So we're going to be starting off with, so what we're going to be starting off with is solving exponential solving exponential equations. Exponential equations by expression each side, expression each side as the power of the symbol. Also, if b power n is equal to b power n, then n is equal to n. Example, this is the example one is example one is says solve 5 power 3x minus 6 is equal to 125. So by this property, if the bases are the same, then we can equate the powers. And we know that 125 can be expressed as a power of 5. 125 is 5 power 3. So now because the bases are the same, we can equate the exponents and solve for x. So from here, we can say that 3 minus 6 is equal to 3. And so if we add 6 on both sides, we have 3x is equal to 3 plus 6, which is equal to 9. And if we divide both sides by 3, we get x is equal to 3. So the solution set is x is equal to 3. And let's look at another example again on this. So this will be example 1b. Example 1b, and it says 8 power x plus 2 equals to 4 over x minus 3. So the property we are using to solve these expression is that we want the base to be the same. We want to express the base on both sides to be the same so we can equate the powers. So we know that 4 and 8 we can express both as powers of 2. So this becomes 8 is 2 power 3, and we have x plus 2 is equal to 4 is 2 power 2, and we have our x minus 3. So this becomes 2 power 3 times x plus 2. This becomes 2 power 2 times x minus 3. And so we can equate the powers now. So this is 3x plus 2 is equal to 2x minus 3. And so if we multiply through by 3 on the left, we have 3x plus 6. And if we multiply 2 by 2 on the right, we have 2x minus 6. And so let's group the x's on one side. So 3x minus 2x is equal to negative 6 minus negative 6. So 3x minus 2x is x, so x is equal to negative 12. So the solution set is negative 12. Let's look at one more example using this property. So this will be our example 1c. And it says 625 power x is equal to 1 divided by square root of 5. All right, so 625 can be expressed as a power of 5, and square root of 5 can also be expressed as a power of 5. So 625 is 5 times 5 to the power 4. So 625 is 5 power 4. Um, 625 is 5 power 4. All right, let me go to another page. So example, this is example 625 power x is equal to 1 divided by square root of 5. So 625 is 5 to the power 4. So 5 to the power 4 x is equal to 1 divided by square root of 5 is 5 power 1 half. And 1 divided by 5 power 1 half is 5 power negative 1 half. Okay, so now we have the bases to be the same, so we can equate the powers. So from here, we can say that 4x is equal to negative 1 half. And if we divide both sides by 4, then we have x is equal to negative 188 as our solution set. So the next thing we want to discuss is using logarithms to solve exponential functions. Using logarithms to solve exponential equations. Using logarithms to solve exponential equations. So the steps to using logarithms to solve an exponential equations involve we have to isolate the exponential expression. So let me write the steps down so we would remember. So one is isolate the exponential expression. So next is to take the common logarithm. Take the uh, take the common logarithm on both sides of the equation. Um, you take either the common logarithm or the natural logarithm, or you take the natural logarithm on both sides, or take the natural logarithm on both sides. of the equation. For other bases, that have 10. And the next step will be to simplify using one of the following properties. So either the log of b power x is equal to x log b, which is the power rule, or log of e power x is equal to x, or the log of 10 power x is equal to x. Then afterwards, we can solve for the variable. All right, so let's use an example. So this would be example 2a. This is solve 5 power x is equal to 1, 3, 4. 5 power x is equal to 1, 3, 4. All right, so the first, and let's take a natural log on both sides. So this would be log of 5 power x is equal to the natural log of 1, 3, 4. Right, and then by the power rule, this becomes x natural log of 5 is equal to the natural log of 1, 3, 4. And we can divide both sides by the natural log of 5. And this becomes x is approximately equal. If we use our calculator to evaluate natural log of 134 divided by natural log of natural log of 5, we'll get approximately 3.04. So the solution set is natural log of 134 divided by natural log of 5. All right, so let's look at another example. So this is example 2b. And this is solve n power x is equal to 8,000. So let's take common log on both sides. So log of n power x is equal to the log of 8,000. So we are using common logs here because we have a 8,000 can be expressed in tens, and we have a 10 on the left also. So using variance will make it easier to evaluate this. So this is x log of 10 is equal to the log of 8,000. So we divide both sides by log of 10. And we divide this side also by the log of 10. So x is equal to if we evaluate this on our calculator, we'll get x to be approximately equal to about 3.9. So the solution set is log of 8,000 divided by log of 10. All right, let's also look at another example. So this would be our third example. So it would be example 3. And this is so 3 power 2x minus 1 is equal to 7x plus 1. Okay, so we can take natural log on both sides, so that will give us the log of 3 power 2x minus 1 is equal to the natural log of 7x plus 1. And so this becomes 2x minus 1 times the natural log of 3, which becomes x plus 1 natural log of 7. Okay, so we can expand from here. So we have 2x natural log of 3 minus natural log of 3 is equal to x natural log of 7 plus natural log of 7. And so we can group the terms with the x on one side. So we have 2x natural log of 3 minus x natural log of 7 equal to the natural log of 7 plus the natural log of 3. And so we can factor x out of this. So we have x 2 log of 3 minus log of 7 is equal to the log of 7 plus the log of 3. And so we can divide both sides by 2 natural log of 3 minus natural log of 7. This is 2 natural log of 3 minus natural log of 7. Okay, so x is equal to the natural log of 7 plus the natural log of 3 divided by 2 log of 3 minus the log of 7. And if we evaluate this on our calculator, we will get approximately 12.11. So the solution set is the exact, which is log of 7 plus log of 3 divided by 2 log of 3 minus log of 7. All right. All right, so let's look at the next thing we want to discuss is using the definition of logarithms to solve a logarithmic equation. So using the definition of a logarithm to solve logarithmic equations. All right, so yeah, um, we are going to use the definition of logarithms to solve logarithmic equations. So let's use an example to begin. So this will be our example for a, and it says so log to the base 2 of x minus 4 is equal to 3. So here we are going to use the definition of logarithms, or the interchangeability of a logarithm to an exponential form to solve this. So by the definition of logarithms, this expression here is equivalent to 2 power 3 is equal to x minus 4. Uh, so this means if we add 4, on both sides, 2 power 3 is 8, so 8 is equal to x minus 4. And if we add 4 on both sides, we get x is equal to 4 plus 8, which is 12. Okay, so let's look at another example, and we can check if our answer is right or wrong by doing this. So let's do a check. So a check will be log base 2 of, we say x is 12, so 12 minus 4 is equal to 3. So this is the log to the base 2 of 12 minus 3 is 8 is equal to 3. 8 is 2 power 3, so this log to the base 2 of 2 power 3 is equal to 3. And this is the same as 3 log to the base 2 of 2 is equal to 3, right? And the log to the base 2 of 2 is 1. So this means we have 3 equals to 3, which is true. So the solution set is 12. The solution set is indeed 12. And we've checked, we've done a check to make sure that the answer x is equal to 12 is correct. So let's look at another example. This should be our example 4b. Example 4b, and it says 4 log of 3x is equal to 8. 4 log of 3x is equal to 8. So here the first thing is we can divide both sides by 4. So if we do that, then we have log of 3x is equal to 2. And remember, natural log means log to the base e, right? So we can write this as, so natural log, remember, is the same as the log to the base e. So this is the equivalent to log to the base e of 3x is equal to 2. So we can write this as e power 2. By definition of logs, we can write this as e power 2 is equal to 3x. And if we divide both sides by 3, then we have x is equal to e power 2 divided by 3. And we can run a check to see if this value of x is correct. So let's do a check. So a check will be 4 times the natural log of 3 times e power 2 divided by 3 is equal to 8. So this 3 will divide this 3. So we have 4 natural log of e squared is equal to 8. And we know that this is also equal to 4 times 2 natural log of e, which is equal to 8. And 2 natural log of e is 1. So we have 4 times 2 is equal to 8. So we have 8 is equal to 8, which is true. So the solution set is e power, the solution set is indeed e power 2 divided by 3. Okay. Let's look at example 5. Example 5. Example 5 says solve log x plus log x minus 3 is equal to 1. So we have log of so by the addition rule, we can condense this as log of x minus 3 is equal to 1. All right, so this is a common logarithm. So it means there is a base 10, which we typically don't write. So using the properties of logarithms, we can write this as 10 power 1 is equal to x times x minus 3. And this x times x minus 3, we can expand it as x squared minus 3x. So you see we have x squared minus 3x minus 10 is equal to 0. So we now have a quadratic equation which we can solve as x squared minus 5. We can write 3x, negative 3x as minus 5x plus 2x minus 10 is equal to 0 because the factors of 10 are 2 and 5, so we can express minus 3x as minus 5x plus 2x. So here we can factor x out of here, x minus 5, and we can factor 2 out of here, so 2 times x minus 5 is equal to 0. So we have x minus 5 times x plus 2 is equal to 0. So x minus 5 is equal to 0, which means x is equal to 5, or x plus 2 is equal to 0, which implies x is equal to negative 2. All right, so we have two values of x. So let's check to see if both values make the equation to be true, or there is only one that makes it to be true, and that one will be part of the solution set. So let's run a check. So for x is equal to 5, we have log of 5. Let me write the original equation first. So the original equation is log of x plus log of x minus 3 is equal to 1. So when x is equal to 5, so we have log of 5 plus log of 5 minus 3 is equal to 1. So we have log of 5 plus log of 2 is equal to 1. And so by the product rule, this is the same as log of 5 times 2, which is equal to 1. And this is the log of 10, which is equal to 1. Log of 10 is 1. So 1 is equal to 1. So this is true. So this is true. So the solution, let's check for x is equal to negative 2. X is equal to negative 2. We have log of negative 2 plus log of negative 2 minus negative 3 is equal to 1. And we don't find the domain of log does not include a negative, right? So let me write this down. So the domain So x is equal to -2 cannot be part of the solution. The domain of the logarithmic function consists of positive numbers only. Consists of positive numbers only. So we don't find the log of a negative number. That means the solution set is only the solution set consists of only 5. The solution set consists of only 5. All right, so the video for 4 point for section 4.4 will be in 2 parts. So this is the first part, and so we will end this here, and we will continue with part 2 of this section in another video. Okay.